All right, quadratic functions. The first thing it talks about is how do you distinguish between whether or not you have a quadratic or if you have a different type of function. One function that we did a lot with last semester were linear functions. You'll notice in the linear function that it just has x to the first power. It can be written either way, like this, x to the first power with a y in there or without the y, the f of x. It doesn't matter. It's still a linear. You'll notice in the quadratic, however, that we have an x squared. All right, so in the quadratic, your x value is to the second power. And this is always going to be the case for quadratic. If you do not have an x to the second power, you don't have a quadratic. If it is to a higher power, then you have a different polynomial. So quadratic has to be x to the second power. Let's talk a little bit about standard form. We talked some about this in standard form when we did the quadratic formula. Ax squared plus bx plus c. This is right there in the middle of the page. This is the standard form for this. We're going to do two different forms. We're going to do standard and vertex form. The first form is standard, ax squared plus bx plus c. You'll notice that your y is on the other side. So we have the y or the fx by itself. The a is the coefficient for the x squared. The b is the coefficient for the x. And the c is your constant. All right. This term with the x squared is called your quadratic term. The term with just the x to the first power is called your linear term. And of course, if it doesn't have a variable, that is called a constant. All right. The graph of this, we've actually done this graphing before. So the graph of a quadratic is always going to be a parabola. All right. It will always be a parabola. It's going to be almost like a U shape, not quite. And whether it's going to be skinny or stretched out will depend on what happens in front of the parabola. Whether it's going to be up or down will determine what happens in front of the parabola, but it will always be a parabola. All right, different things can move it around, but if it is an x squared, it's always going to be some type of parabola. So key features of the parabola. The first thing you'll notice is this dashed line going down the center. The dashed line going down the center is called the axis of symmetry. Axis of symmetry. The slope of your axis is undefined. This is a vertical line, so the slope of the axis is undefined. But this is your axis of symmetry, a line with an undefined slope that goes through the center of the parabola, making it symmetrical on both sides. So directly down the center of your parabola is your axis of symmetry. The equation of this will always be x equals a number. In this case, the example that they give you on your sheet, you'll notice that vertical line goes through -1 on the x-axis. So your equation is x equals -1. So anytime I ask for the axis of symmetry, I am asking for x equals some number. Where is that center line that goes through it? You'll notice it is dashed. Remember, anytime you graph a line and it's dashed, it means it's not actually part of the equation. The axis of symmetry is not part of the parabola. It is just a line helping you see where it is symmetric and what is it symmetric to. So this line helps you graph it, but it is not actually part of the graph itself. All right. The next thing that they point out here is where it crosses the y-axis. So right here, you'll notice that our graph crosses the y-axis. So this is my parabola right here. And you'll notice that the point where it crosses the y-axis is right here at -3. And so that is called the y-intercept. Y-intercept is the place where the parabola crosses the y-axis. It's where it crosses the y-axis. All right. This is also a particular point that you're going to want to find, and we're going to talk about different ways to find these depending on what you have. But it also helps you graph because you'll notice that the y-intercept right here is 1 away, in this case, from your axis. And if it's symmetrical, you can go 1 away on the other side and you have a second point. So when you're trying to graph these, if you can find your axis and your vertex, which we're going to get to, then you can graph it using your y-intercept if your y-intercept is on your graph. All right, let's look at some others. Vertex. So this point where the parabola turns, that is called your vertex. The point where it turns. In this case, it is the minimum. If this graph were pointing down, it would be the maximum. So it is called the minimum when it opens up because it represents the lowest point. When the parabola opens down, it is called the maximum. So if the parabola is pointing up like this, then your vertex is going to be the lowest point. It's going to go to the lowest point and turn, minimum. If the graph were going down, pointing down, then where it turns would actually be the highest. Think of like throwing a ball up in the air. The ball is going to go up to its highest point. It's going to turn and come back down. So if this parabola were pointing down, that would be the max. Since it's pointing up, it is the minimum. Then you'll notice that there are two places where this graph crosses the x-axis. These are called your x-intercepts. There are other names that it is called: the root, the solution, and the zero. We're going to get into all of those, but those are other names for the x-intercept. If it is called a root or a solution to the quadratic or a zero, those are all names for the x-intercept. All right. You'll notice the graph of just the plane x squared is this black line here. It's a perfect parabola right there. When they multiplied it by 2, it stretched it this way. So you'll notice it moved towards the y-axis here. When they multiplied it by a -1/2, two things happened. One, the negative flipped it upside down, so you see that it is pointing down. You'll also see that the fraction stretched it wide, and so it's wider than the original, where this is narrower than the original, okay? So a whole number in front of it will make it narrower. It'll actually pull it this way, up and down. Fraction will actually pull it out, and it will stretch it that way, all right? Positive numbers will be pointed up, negative numbers will be pointed down. A couple other things that happens with these graphs. When you add and subtract, you'll notice that same graph. So this is 1/2 x, so it's a little bit wider than an original just x squared. You'll notice when they added 3 to it, it shifted the graph up. When they subtracted 4, it shifted the entire graph down. And so just like when we've graphed other things in the past, and adding and subtracting inside and outside moves it around, that's what happens here as well. All right? So let's look at the effects of these. If a, remember a is the number in front of your x squared. If it is positive, the graph will be up. If it is negative, the graph will be down. If the graph is up, you have a minimum. If it's down, you have a maximum. If the absolute value of a is greater than 1, so if it's a 2 or a -2, it doesn't matter as long as it's not less than 1 for absolute value, it's going to stretch it this way. So you're going to see that it is going to skew it and it's going to pull it taller. If the absolute value of a is less than 1, meaning it's a fraction, you'll see that it's going to push it this way. All right? And if you have a plus or minus, if you're constant, you have a constant added to the end of this, it's going to shift the graph up and down. And we're going to see how it shifts it left and right as well. All right? Let's look at some more features of standard form. All right. You can factor to find the roots. You can automatically see your y-intercept. You know the width and the direction. All right, so let's talk about what these coefficients and constants tell us. The A, the A will tell us the width and the direction. So depending on what is in front of the A, it'll tell you if it's wide or narrow, and it will tell you if it goes up or down. All right, so A is going to tell you if this point's up or down. It will also tell you if it's narrow or if it's wide. B is going to move this thing diagonally, left and right, up and down. So left and right is going to be basically what your B moves it. Up and down is what your C moves it. So you'll find that the C also is going to help you find your y-intercept. Okay? In fact, the C will be the y-intercept. Anytime you look at your C value, you can automatically assume that your y-intercept is this, as long as it is in standard form. So as long as this is in standard form, then you know that you have your y-intercept automatically given to you there. That is your y-intercept. So we can factor this. We can automatically see the y-intercept. We know if it's pointing up or down. We know how wide it is automatically from this. All right? Automatically from this. Let's look at other features here of these. If A is positive, in standard form, it will go up. If A is negative, it will go down. All right, so these are the things we just talked about from your book. We're just filling it in. If the absolute value is less than 1, the parabola will be wide. If the absolute value is greater than 1, the parabola will be narrow. It will be narrow. All right. B. B causes the parabola to shift diagonally away from the y-axis. C is the y-intercept. So whatever your C is, then that is going to be your y-intercept. If the y-intercept is positive, it will shift up. If it's negative, it will shift down. All right, they've given us a picture at the bottom of a quadratic. So when I'm just looking at this, I know my A value is positive. So I know that my A value is positive because it is pointing up. All right, it is pointing up. And we'll get to how we know that it's 3 in just a little bit. Roots. Remember, roots are also another way to say x-intercept. Well, if I look here, I have an x-intercept at -3 and -1. That's how I know those are my roots, because those are also x-intercepts. That's another way to say x-intercept. And we're going to talk about factors in a little bit. My y-intercept, well, if I look here, my y-intercept is 9, so I can assume that the value of C is 9, And we're not going to do this part of the equation just yet. We're going to get to those. So I can tell that my A is positive. I can tell what my roots or my x-intercepts are. I can also tell what my y-intercept is as well. All right. So when it is in standard form, you have a specific way that you find the axis of symmetry. So this is only when it is in standard form. How do I find my axis? The way you find your axis is you take your negative b, remember what your b value is, and you put it over 2 times a. So we are going to do that with this specific one. B is 8, all right? B is 8. So we're going to say -8 over, my a is -2, all right? So 2 times a. So I end up with -8 over -4. You do want to reduce that. That is 2. The way I would write my axis is I would say x equals 2. X equals 2. Negative b over 2a is your shortcut to find your axis when it is in standard form. Negative b over 2a. How do I graph my axis? My axis is always a vertical line at that number on the x-axis. So if I want to graph this, then I am going to go to +2 on my x-axis, and I am going to draw a vertical line. Vertical line. All right, now in this case, I am going to dash that line, because remember, this is not actually part of my graph. This is just a line that helps me see what my graph is going to look like. So it's always going to be this vertical dashed line. That is how you graph your axis of symmetry. All right? It's always x equals, and you're going to say -b over 2a. All right? The next thing we're going to find then is the vertex. The vertex. So my vertex is going to be my axis, whatever that was, and then the y value when I plug in my axis, all right? So in this case, what was my axis? Well, my axis was 2. So my x value of my vertex here is going to be 2. Well, I need to find my y value. Well, how do you ever find a y value? You plug it in, all right? So I'm going to take my function here, and I'm going to plug in that 2. So I'm going to say -2 times x squared. My x is 2. 2 squared, plus 8 times my x value, which is 2, minus 9. I'm just plugging it into my original equation. Negative 2x squared plus 8x minus 9. So everywhere I have an x, I'm plugging in that number I just found for my axis, okay? And then you just do order of operations. Remember, we're going to do exponents first, then multiplication, division, then addition, subtraction, okay? We don't have any grouping here. So in this case, I'm going to take this 2 and square it. So 2 squared is 4 times negative 2. I have a negative 8 plus this 8 times 2, 16. And then I have minus 9. Okay? All right, so I have negative 8 plus 16 minus 9. All right, that gives me positive, or negative 1 rather, negative 1. So that's going to be the y value of my vertex, all right? Negative 1. So my vertex is always, while my axis of symmetry is always a line, my vertex is always a point, all right? So my axis of symmetry is going to be x equals something. My vertex is going to be an xy value, xy value. And so now to plot that point, I go to the point 2, negative 1. That's right here. And I'm going to plot that point, all right? The last thing my instructions tell me to find is my y-intercept. Well, y-intercept is actually really easy to find. Okay, for y-intercept, you are going to just use your c value. Remember, when it's in standard form, your y-intercept is always going to be your c. In this case, my c is negative 9. So my y-intercept is going to be 0, negative 9. So when it's in standard form, your y-intercept is just 0, c. In this case, 0, negative 9. Well, how do I graph that? I go to my y-axis and I go to negative 9. Okay? So now I have my axis of symmetry, my vertex, and my y-intercept. The last piece of this instruction says sketch the graph. Well, it's a parabola, so I really need to have a point on both sides of the axis of symmetry. This part's really easy. You're just going to mirror it, okay? So if I have a point right here, then that means that there's going to be a point exactly the same on the other side. So just mirror it. This point right here is 1, 2 away from my axis of symmetry. That means I have another point that is 1, 2 away on the other side. So I can just mirror that over here and put that point. Now let's use our logic. If my vertex is up there in the blue point, 2, negative 1, and my y-intercept is way down below it, it means this guy is going to be pointing down. Well, let's confirm that with our A. Is our A positive or negative? Positive. Our A is negative 2, right? And so if our A is negative, it should be pointing down. So that indicates that I've probably done this correctly. And so to actually sketch this graph, I'm going to connect these points. I'm just going to draw my parabola like that. And because it's a 2, right, the absolute value is greater than 1, it should be a little bit skinnier than a standard parabola. It should have made it more narrow, and it would have done that as opposed to if it was a 1 or if it was a fraction, all right? So let's go over it really quickly. Axis is negative b over 2a. Find that, and then it's x equals that number. Vertex. The x value of your vertex is whatever you found for your axis of symmetry. Your y value is what happens when you plug it into your equation. And then your y-intercept is just 0c. Once you have all those pieces, you should be able to sketch your graph by mirroring that point. So just think of this as another way to write the same type of equation. You'll notice that it does not have a B or a C. It has an H and a K. And as we've done in the past, when you have something inside parentheses, it moves it left and right, okay? It moves it left and right, opposite of how you would think it would move it. So you'll notice when it said x minus 2 here in the parentheses, it moved it right. And then when it has x plus 3, it moved it left. So it moves it opposite of how you would think. You'll notice that in the standard form, this is a minus here, all right? A minus. And so it's always going to be the opposite of what you think it's going to be when you're talking about that H value, all right? You can have both things happening. You can have it moving left and right and up and down. And you can see that inside, it moved it right 2 places and it moved it down 3. So you'll see that vertex shifted from the origin, 0, 0. It moved left 2 and then it moved down 3. And so that's what vertex form is going to help us do. Instead of having to calculate the vertex form actually gives it to us, kind of hands it to us. The standard form of vertex is A times the quantity x minus h squared plus k. All right? So let's look at what all of these stand for. Why do we like it? You can very easily find your axis and your vertex when it is in standard form. All right? Your A still tells you your width and direction, but the H now tells you the value of your axis and the X value of your vertex. The K now tells you the Y value of your vertex. So when you have it in vertex form, you don't have to solve for your axis or your vertex. You actually already have that. The only thing you have to solve for when it is vertex form is your y-intercept. All right? So the A still tells us the width and the direction. It still tells us if it's narrow or broad. It still tells us if it's pointing up or down. The H now tells us the axis, and it also tells us the X value of the vertex. The K tells us the Y value of the vertex. All right? So you can have the same 2 equations written 2 different ways. All right? Same 2 functions written in standard form or in vertex form. All right? So let's look at what happens. This is identical with the A. The A is identical in standard form and in vertex form. If it is positive, it goes up. If it's negative, it goes down. If the absolute value is greater than 1, it's going to be narrow. If the absolute value is less than 1, it is going to be wide. Negative H is the X value of the vertex. Remember, your formula already has a minus in it. So you'll notice that this guy right here is a negative H. Negative H is the X value of the vertex. H causes the parabola to shift left and right. Negative H will shift it right. Positive H will shift it left. K is the Y value of your vertex. You'll notice that it is not negated, so whatever the K is the value you're going to use. It moves it up and down. Negative moves it down. Positive moves it up. Listen to this last statement. K is not your Y-intercept. All right, in standard form, you don't have to solve for y-intercept. It's just handed to you. But when you are in vertex form, this is the only one you have to solve for. All right, so in vertex form, you have to solve for your y-intercept. That K does not represent your y-intercept. Same graph. You can see your vertex now is -2, -3, so you know your H and K value. A is still positive. It points up, so we know this is positive. The formula for the vertex is going to be your H and your K. And then we're going to talk about equation, but we will be able to then pull the equation from these. So you can now see H and K, which before we actually couldn't see that. The thing we don't automatically see in our equation here is your y-intercept. So you'll notice that's not even mentioned here because it's not part of your vertex form equation. All right, let's look at the back page of your handout. The back page, these are in vertex form. We are going to do 5 together. All right, so first let's look at this graph here. My A value is 1. If you do not see an A value, it is a 1. My h value is also 1. It is not negative 1. It is positive 1 because my h is already after. So for h, you're going to do the opposite of what you think. This shows a -1, so your h is going to be 1. My k here is 4. So let's see what happens when I try to find my vertex, my axis, and all that good stuff. So for axis, my axis is just going to be x equals h. That's what's going to happen here. Remember, it's going to be the opposite. So if you need to write negative h there, you can. It's going to be the opposite of what you think. So in this case, my axis is going to happen at x equals positive 1. That's where my axis is. I do not have to solve for it. It's going to be right here at positive 1. My vertex. My vertex is going to be HK. Remember, it's the opposite of what you see there. So in this case, my vertex is going to be positive 1, positive 4. I don't have to solve for that. Positive 1, positive 4, and I can put that point right there. Positive 1, positive 4. My y-intercept is what I have to solve for. So for y-intercept for vertex form, I have to plug in a 0. It is going to be 0 and then the y value when you plug it in. So I'm going to take this equation. It's x minus 1. So I'm going to say 0 minus 1 squared plus 4. You have to do order of operations. 0 minus 1 is negative 1. Negative 1 squared is 1. 1 plus 4 is 5. So my y-intercept here is going to be 0, 5. And I am going to plot that point. Now you'll notice my y-intercept is above my vertex. All right. Which is how it should be. My A is positive, so this guy should be pointing up. To find one more point, I'm just going to mirror that y-intercept. So my y-intercept is 1 away from my axis. So I'm going to move 1 away on the other side and mirror that point. And now I have those 3 points and I can graph this. So I'm going to graph this parabola. So go ahead and try number 6. Find your axis, find your vertex, find your y-intercept, and then graph it. In your book, example 4. So this is actually on page 243 in your books. There are times when they will ask you to convert. This says by completing the square. I actually do it a different way. So if I'm going to convert from one form to the other, I'm actually just going to either, if it's going from vertex to standard form, I'm just going to FOIL that parentheses and distribute and add. If I'm going from standard form to vertex, I'm just going to find my vertex. My A is going to stay the same. So in this case, my A for this function is just 1. So I'm going to try to go from standard form to vertex form. My A here is 1. That's going to stay the same. What I need here is my H and my K. That's what I need to find. Well, H and K is just the X and Y of your vertex. So if I find my vertex on my standard form, I can just plug that in and that will be my vertex form. all right? And so that's what I'm going to do. I'm going to find my negative b, that's negative 3, over 2 times a. And of course, they gave me a fraction because that's nice of them. All right, so going to find that guy. And then I'm going to plug it in to figure out what my y value is. So negative 3/2 is my h value. And remember, I'm subtracting, so that's negative 3/2 goes there. And then to find the y value of my vertex, remember, I just plug him in. So I have negative 3/2 plugged in. All right. And you can do your order of operations here. So that's going to be 9/4 plus 9/2. That's a negative, so minus plus 1. This guy's going to be negative 18/4, so we have to get a common denominator. And I'm going to change that to 4/4, all right? So we have positive 9 minus 18 is negative 9. Plus 4 is negative 5. So this is going to be negative 5/4. So that's my k value. So my h value is my axis of symmetry, how I find that, or the x value of my vertex. The k value is going to be the y value of my vertex. All right, so if I find my vertex, in this case, my vertex was negative 3/2, negative 5/4, I found my h and my k, and I just plug it in. Now I'm going to make this look a little prettier here. I don't need the 1. I wouldn't say minus, minus. I would say plus. And I wouldn't say plus a negative. I would just say minus. But if you're converting from one to the other, as long as you have your vertex, you can actually just plug it in. All right, so if I'm converting from standard to vertex form, I really just need to find my vertex, and that is my h and my k of my vertex form. All right? But I want to talk about what it's asking for. They give this projectile its shot. It gives my initial velocity, and then it gives me the function. The function is what's important here. All right? The function is what is important here. It says, what is the maximum height it will reach? Is this parabola pointing up or down? And how do we know? Yeah, it's pointing down, and how do we know? Negative in the A. So I know that this projectile was shot up, and then it came back down. Okay? That's what I know about this projectile. If it wants to know the maximum height, what is going to be my maximum height of a parabola that points down? The vertex. And so when they ask for maximum height or minimum height of a parabola, they are literally just asking for the vertex. Typically, the y value of the vertex, because that's what represents your height, okay? So when you see a huge word problem like this and you see an x squared, they're literally just giving you a parabola. All right, your homework is to finish the handout. So 3, 4, 7, and 8 on this handout is your homework. 3, 4, 7, and 8.